We are going to do Challenge Yourself, chapter 15 from D3 Mathematics. It's about probability. So we have two questions in this Challenge Yourself. So let's do one by one. So question one is about a standard pack of cards. So let's go through the question first and then we solve it. So a standard pack of 52 playing cards is randomly divided into two unequal piles. So first of all, we have like two piles of cards, 52 cards. So they are unequal number of cards. So some cards are in pile one and some in pile two. Let's call it like pile one or smaller pile. So let's call it S, pile S and smaller pile, and pile L, larger pile, right? You can give any name to these. So given that the probability of drawing a picture card from the smaller pile is 4/11, while the probability of drawing a non-picture card from the bigger pile is 13/15. We have to find the number of cards in each pile. I suppose everybody knows about formation of standard pack of 52 playing cards. Just like a quick reminder, so total cards are 52 and it consists of 4 suits. So we call it like heart, diamond, spade. So I'm just drawing roughly, and then we have clubs. So each card, each suit has 13 cards in it. So these cards, each suit, so it's numbered from 1, we call it ace, and then 2, 3, go all the way up to 10, J. So it's 9, J, Q, and K. So 11, 12, 13. So J, Q, K, these three cards are called picture cards because there's drawn picture of Jack, Queen, and King. So altogether, how many picture cards we have? 3 from each suit. So we have 3 into 4. 3 into 4, we have got 12 picture cards altogether. Okay. So over here, now we have got probability of picture card from the smaller pile of cards as 4/11. So let's suppose number of cards in smaller pile is number of cards in S pile. Smaller pile is equal to X. So if X cards are in smaller pile, how many cards should be in larger piles? So number of cards in L pile, the larger pile. So it has to be 52 minus X. Total cards are 52. X are in smaller pile. So 52 minus X cards should be in larger pile. No, how many picture cards are there? So probability of picture cards in smaller pile is 4/11. So probability picture cards in S is equal to 4/11. So how many picture cards are in S? We have to multiply 4/11 by X. So let's call picture cards in S is equal to probability into number of cards. So 4x/11. Now let's see how many picture cards are there in larger pile. So what we are given is probability of non-picture cards is 13/15. So probability in L pile, larger pile. So we have non-picture cards. So cards could be either picture cards or non-picture cards. So if you are given non-picture card as 13/15, then probability of picture cards in larger pile cards in L. So it has to be total probability minus 13/15. Total probability is always 1. So 1 minus 13/15. So we get 2/15. So 2/15 is probability of picture card in larger pile. So if we want to find number of picture cards in pile L, so we have to multiply probability into number of cards in larger pile. So it's going to be 2/15 times number of cards we already said it's going to be 52 minus x. So we multiply it with 52 minus x. And now, how many total cars were there? So we have decided, figured it out. Total picture cars are 12. So if we add our equation 1 and equation 2, cars in smaller pile plus cars in larger pile, so it has to be 12. So we add these two and sum these, so the summation should be equal to 12. So I just add them up here on right hand side. So we have got 4 over 11x. I'm just writing 4x over 11 plus 2 over 15 into 52 minus x. This is equal to 12. Now I just have to solve this algebraic equation. Keep x side on one side and all other constant things on the other side. I can write down 4 over 11x. One way is you just take LCM here and then do cross multiplication. The other way is to simplify it first and then do arrangement and LCM, all this stuff. Minus 2x over 15 is equal to 12. I keep x terms on this side and move rest of them on the other side. 4 over 11x minus 2x over 15. So this is equal to 12 minus 2 over 50 times 12 will go on the other side. 2 times 52 is 104 over 15. I just have to solve this thing. So I solve over here. I got some space over here, so that should be enough space to solve this equation. So for this, first I take LCM. 15 times 11 is 165. And we have got 4 times 15. 165 divided by 11 is 15, so 4 times 15 minus 15 divided by 165 divided by 15 is 11. So 11 times 2 is, okay, I just started 2 times 11. And we have to keep x over here is equal to, on the other side also we can take like 15 as LCM. 15 times 12 is 180 minus 104. So 15 times 4 is 60 minus 22 divided by 165. This is times x. So this 76 over 15. So bring 165 on other side. So we will get 165 times 76 over 15. So we can divide 165 by 15. First 60 minus 22 is 38x is equal to 76 over 15 times 165. So this is cancelled. We get 11. So 76 times 11, we can use calculator or just we can multiply like that. So this is 836. So now divide 836 by 38. So again, use calculator, we will get the answer 22. And you can use calculator. I've just done mental multiplication, but you can use calculator. So x is 22 in smaller pile in S pile. So value of x is equal to 22. So larger pile, it was 52 minus x. 52 minus 22. So this is going to be 30 cards in this pile. So we have solved this problem. The main thing over here is first we have to understand the structure formation of 52 cards. And the other thing is whenever we have to find total number of cards, we have to multiply it by 4 over 11 with this probability. Total number of cards, and we want like some particular type of card whose probability is given to us. So we have to multiply it by 4 over 11 into total number of cards to get those particular cards. So that was question number 1 of challenge yourself. Let's move on to question number 2. So this is about counting. Counting is we are counting number of ways for a particular problem, in how many number of ways we can solve a particular problem. So let's see. First of all, try to understand the problem. So over here it says Rui Fang writes 3 letters to his friends, Fran, Vishal, and Michael. He types each of their addresses on 3 envelopes and puts the letter into envelopes randomly before he sends them out. So he put the letters randomly into envelopes. So some of letters may go to right envelopes and they may not go to the right envelope. So we have got 3 letters. So let's name them, let's say ABC. So let's call it A, B, C. These are our letters. And we have got 3 envelopes. So let's name them like 1, 2, 3. So it's kind of mapping, like A is mapped to 1, B is mapped to 2, C is mapped to 3. In that case, it's right order. So A is mapped to 1. Letter A is put in envelope 1. Letter B is put in envelope 2, and letter C is put in envelope 3. So this is correct order. But since he put randomly, it may happen like letter A go to envelope 2, letter C go to envelope 1, or letter B go to envelope 3. So how many possible ways are there? So first we need to find total number of ways. Once we know total number of ways, then finding the probability of all these 3 cases is simply finding number of ways of each case divided by total number of total number of ways. So these are not so many, so we can easily list these down. If there are too many, we can't list them down, then there are ways to count these. Over here, we simply list them down. So one way is, I'm just listing it down. So one way is A goes to envelope 1. So I'm just writing like A1, and B goes to 2, and C goes to 3. So this is the correct order. Every letter goes into right envelope. What other combinations could be? Let's say A goes to its correct envelope, A1, and B and C are switched. B goes to 3 and C goes to 2. So this is a different order. What else can be done? Maybe B, we put it in the right envelope, and A and C goes into wrong. A goes to, let's suppose, 2, and uh, first we can go in order. So A1, so we list down for A2. So for B, we put first B1 and C as C3. And we can switch again B and C. So A2, B3, and C1. And third way, sorry, these are 4-way. Another possibility could be A goes to third envelope, and B goes to first, C goes to second. And if A goes to third, B may go to second, C may go to 1. Could there be any other possible way? No, we have listed all possible ways. So how many total number of ways is? So total number of ways is equal to 6. Now let's have a look at these question and let's try to solve them. So first part says exactly one of his friends received the correct letter. So among all these, which one is like only one person should receive the correct letter? One way is this. A goes to 1, B goes to wrong, and C goes to wrong. And other way could be like B may go to correct one, B to, A goes to wrong, and C goes to wrong. So exactly one letter goes to the right address. Or it could be C goes to the correct one, B goes to wrong, like it should go to 2, but it's going to in 1, and A goes into wrong envelope. For all other cases over here, it's more than 1. All 3 goes to right. We are looking at exactly one of his friend received correct letter. Over here, A2, B3, C1, all of them are in wrong order. A3, B1, C2, all of them are in wrong order. So we get only 3 ways. There are 3 ways such that exactly one friend receive correct order. Exactly one friend, one person receives the correct letter, right? Correct letter. So if you want to calculate the probability, exactly one. correct. So this is going to be number of ways divided by total number of ways. So number of ways of exactly one letter receiving correctly is 3 divided by total number of ways, 3/6. Always simplify the fractions, we get probability 1/2. So there is a half probability that exactly one of the friends will get correct letter. Question number 2. So exactly 2 of his friends receive the correct letter. So let's see, is it possible actually? So if 2 people have received correct letters, for example, A1 and B2, then C has to be in third one, right? So there's no way that exactly two people will receive right letter. It will be if 2 people have received the right letter, so third will also receive the right letter. Over here we can also see this is all 3 of them get right letter. The first one, this is for 1, 1 and 1, and these are when no one gets the right letter. So there's no way that exactly 2 letters get correct letters. So we can write down probability of exactly 2 is equal to 0. So it's like impossible even for this particular problem. So exactly 2 correct letters, so its probability is 0. Third one, so we can see for third one, answer is already obvious because out of 6 possibilities, 1 is for all correct letters. So 2 are, the 3 are when one friend received the right letter, and there are 2 cases when no one received the correct letter. So part 3 says all 3 of his friends received the correct letter, and there could be only one way. I mean, this is so obvious. So probability of all 3 receives correct letter. There could be only one way, of course. So that is 1 out of 6. So the probability is 1 out of 6. So this is called counting method and finding probability based on all possible ways of counting. This is also called enumeration. We enumerate all possible ways and then we calculate probabilities based on our enumerations. Thank you very much.